Hello and welcome to the Sleepy Scientist. I am glad you are here tonight. Before we wander into the red sands of Mars, let me ask you, where in the world are you listening right now? Maybe you are resting in bed, maybe you are stretched out on a sofa, or maybe you are sitting in a quiet corner. Wherever you are, I am thankful you joined. If you enjoy these calm journeys and want more, please give this video a like, and if you have not already, subscribe. It is the easiest way to travel with me. Again, also turn on the notifications so you know the exact time our next adventure begins. For you it is small, for me it means the world. It keeps this little community of gentle curiosity growing, and for those already subscribed, thank you. You are the reason these voyages keep moving forward. I will try to keep this soft enough to help you rest, though I admit sometimes Mars is so fascinating it may keep you awake. If that happens, at least you will have a head full of cosmic facts, so let us begin. What if the quietest place in the solar system is also one of the most mysterious? Mars, our small rust-colored neighbor, has captured human wonder since the first night sky was watched. Its steady glow guided ancient astronomers, inspired myths of gods and warriors, and stirred dreams of life beyond Earth. Yet behind that red shimmer is a world stranger and more beautiful than its distance suggests. In the journey ahead we will not rush, we will pause on the frost that creeps across Martian dunes at dawn. We will listen to the whisper of wind moving the dust, and we will trace the scars left by ancient rivers. We will travel through canyons so vast they could swallow whole countries, climb mountains stretching nearly to the edge of space, and hear the thin air sighing across stone. Along the way we will explore how this world was formed, how it may once have been blue with oceans, how it lost the shield that guarded its skies, and how its story can teach us about our fragile planet. There will be stories of machines too, rovers with wheels and wings built to endure the cold, to taste the soil, to send back images of places no human has walked. This is not only the story of a planet, it is the story of a companion, steady and quiet in the dark, and our longing to reach it. So let us drift together toward the red horizon, where every grain of dust carries the memory of a world that could have been. If you stood outside on a clear night and looked up, Mars would appear as a small steady point of rusty light. Unlike the white sparkle of most stars, it glows with a warm ember, millions of miles away. This red color made it special for ancient watchers. They noticed not just its hue but its motion. Most lights in the sky stayed fixed, moving together as hours passed, but some wandered. Mars was one of them. Before telescopes, people saw that Mars drifted eastward most of the year, but then paused, moved backward westward, then forward again. This loop is called retrograde motion. For early observers it was a puzzle. To the naked eye it almost seemed Mars had a will, stopping mid-journey as if reconsidering its path. Civilizations gave it names and stories to match. The Babylonians called it Nergal after their god of war. The Greeks named it Ares. The Romans called it Mars. The red tint linked the planet to blood and battle. Even though in truth its deserts are cold and empty, still the image stuck. In every culture Mars was a figure of power. The loops it traced were one of the oldest mysteries in astronomy. In the geocentric model, where Earth was thought to sit at the center, this strange behavior needed creative fixes. Claudius Ptolemy, a Greek-Egyptian astronomer in the 2nd century, made a system of circles within circles called epicycles. In his model Mars moved in a small circle that itself traveled along a larger path around Earth. It was neat and matched what was seen, but it was only a patch on a deeper misunderstanding. The true answer arrived more than 1,000 years later when Nicholas Copernicus revived the idea that the Sun, not Earth, sat at the center of the system. In this heliocentric model, retrograde motion was not a strange behavior of Mars but a trick of perspective. As Earth caught up to and passed Mars in its orbit, the red planet appeared to move backward for a short time. Like when you pass a slower car on the highway and it looks as though the car is drifting back even though it is moving forward. Once this was understood, the mystery was gone, but the beauty remained. Even without modern tools, ancient astronomers were skilled at following Mars. The Mayans could predict its position years ahead. In India, careful records were made of its loops across constellations. These observations were not just for curiosity. They were used for calendars, farming, navigation, and even politics. Mars with its fiery color was often seen as an omen, not always a gentle one. Then in the 17th century, Galileo Galilei pointed his telescope at Mars. His instrument was simple, just a tube with lenses, but it turned the planet from a wandering point of light into a tiny disk, proof it was not a star but a world with size and surface. Though he could not see details, this alone challenged long-held beliefs. A few decades later, Christian Huygens used a better telescope and drew the first known feature on Mars. A dark triangular shape we now call Syrtis Major. By watching it shift, he guessed the length of a Martian day, just over 24 hours, amazingly close to today's value. Knowing Mars had days and nights like Earth deepened the sense of connection. As telescopes improved, astronomers saw more polar caps that grew and shrank with the seasons, leading some to think they were water ice like Earth's poles. This stirred imagination. If Mars had ice, if it had day length like ours, if its surface changed, perhaps it had life. By the late 19th century, Percival Lowell believed he saw lines crisscrossing its surface, canals, he thought, built by intelligent beings moving water from poles to equator. The idea was appealing but later proven to be an illusion of the eye and mind. Still, Mars had already captured the human imagination simply by its motion, its brightness, and its looping dance across the night. It was always present, but not like the stars. Its gliding, vanishing into the sun's glare, then returning, gave a rhythm that tied nights to the machinery of the solar system. Through Mars we began to understand that the universe is not still. Worlds move, shift, and follow paths that are predictable but never simple. In studying the path of this small red wanderer, we began to learn our own place among them. About 4 billion years ago, the solar system was not calm as it looks today. It was a swirling disk of gas, dust, and ice around a young sun shining dimmer than now. In that disk small grains collided, stuck, and grew into clumps called planetesimals. Those clumps merged into larger bodies, pulled together by gravity. Mars was born in that crowded nursery between the Sun and the asteroid belt. The material there was thinner than near Earth, so Mars had fewer building blocks. This scarcity shaped its fate. Mars became only half Earth's diameter and just 1/10 its mass, a small planet among giants and mediums. Size matters. Larger planets hold heat longer. Their molten cores churn and create magnetic fields that shield the atmosphere. Smaller planets like Mars cool quickly. Their internal dynamo slows and stops. Without a shield, the solar wind strips away the air. The atmosphere thins. Mars changed from a place that might have been blue with oceans to the cold, dry desert we see now. Yet in its youth Mars was not still. Volcanoes erupted and reshaped the land. Some grew to be the largest in the solar system. Olympus Mons rose nearly 3 times taller than Everest and sprawled as wide as France. Its huge size was possible because Mars has no tectonic plates. On Earth, plates move over hotspots, creating chains like Hawaii. On Mars, the crust stayed fixed over hotspots, lava piled in the same place for millions of years, building monsters like Olympus Mons. The early surface of Mars was also shaped by massive impacts. In the first few 100 million years, asteroids often crashed into the young planet. One giant strike may have carved out the Borealis Basin in the north, reshaping half the planet in a single moment. Elsewhere, craters overlapped each other. Some softened or buried by lava, others left sharp and raw. Though destructive, these impacts shaped geology and even climate. Big collisions released energy that heated the atmosphere and melted ice, creating brief episodes of flowing water. In those early days, rivers and lakes carved channels and valleys, their marks still seen from orbit. The flows may have been short and rare, but they hint at a Mars that was once not frozen and dry. Beneath the surface, the planet's interior was alive. Heat from radioactive decay and leftover formation energy kept the mantle partly molten. Magma rose, cooled, and built crust. Over time the heat faded, the mantle stiffened, the crust thickened. Without tectonics to recycle rock and release gases, features stayed preserved. On Earth landscapes are erased and rebuilt. On Mars a riverbed billions of years old can remain almost unchanged. Volcanoes eventually went dormant, though signs suggest eruptions lasted longer than once thought, maybe as recent as a few million years ago, which in planetary time is like yesterday. In the first billion years Mars may have had a thick atmosphere, enough to keep water liquid for longer periods, maybe. With clouds, rain, and snow, but as the magnetic field weakened the atmosphere thinned, solar wind stripped it, and water vanished underground or froze at the poles, leaving dry land. Yet this loss preserved history. Many ancient features remain frozen in time: deltas, lava plains, and craters create a geological scrapbook, each layer a page of the past. Today, when orbiters and rovers look down, they see the results of those ancient forces: volcanoes, impacts, cooling, and atmosphere loss. The same forces that may once have made Mars habitable. Mars may have been doomed by its small size, but it left its record intact: dunes, plateaus, craters, all echoing its fiery youth. If you hovered above early Mars, you would have been surprised by the familiar look. Instead of empty deserts, you might have seen winding rivers, scattered lakes, maybe even seas, still smaller, colder and drier than Earth, but wet enough for water to flow. That brief chapter left marks in stone. Spacecraft in the 1970s showed channels like dried rivers on Earth, some hundreds of miles long, branching into tributaries before merging into valleys. They were not random scars of wind but clear water paths. It looked like a desert where rivers had simply dried away. Closer study showed different forms: narrow branching valleys like rain-carved gullies, deep straight troughs maybe from sudden floods or collapse of underground water, huge outflow channels hinting at catastrophic releases of water that reshaped land in days. Along with these were deltas where rivers spread into fans before reaching lakes. The most famous lies in Jezero Crater, now explored by the Perseverance rover. From orbit the delta's wedge is clear, the same shape seen where rivers meet seas on Earth, proof of calm standing water where sediment settled over time. If life ever existed, this would have been a perfect place, sheltered and mineral-rich. Minerals tell more of the story. On Earth, clays form only after long contact with water. Sulfates appear when water evaporates. Orbiters found these scattered across ancient Martian ground, like chemical fingerprints proving water was once there. In some places clays dominate, showing early water was stable and gentle. Later sulfate spread, showing water became acidic and short-lived. A sign the planet was shifting to cold and dry. Even worlds without forests or oceans can change climate. Comparing early Mars to early Earth shows both likeness and difference. 4 billion years ago Earth was also violent, with impacts and volcanoes, but Earth was bigger, closer to the Sun, and could keep a thick atmosphere. Seas formed and life began. Mars was smaller, with weak gravity. It may have had lakes, rivers, maybe even a shallow northern ocean, but it was on borrowed time. Still, that time might have been enough. On Earth the earliest traces of life appear 3.5 billion years ago, maybe earlier. If Mars had water for hundreds of millions of years, microbes could have started. Water is a great solvent, mixing nutrients. With sunlight, volcanic heat, and minerals, the ingredients were present. The question is how long conditions lasted. Some scientists think rivers and lakes were seasonal or tied to volcanic bursts or orbital shifts. Others think Mars once had a thick atmosphere and long-lived water. Either way, traces show wetter and drier phases leading to today's dryness. Water may not have disappeared fully. Much could have sunk underground, frozen as ice or locked as salty brines under soil. Radar hints at subglacial lakes under the poles, though still debated. If true, they are echoes of a wetter past. The most striking thing is how rivers, deltas, and minerals remain visible after billions of years. On Earth rivers shift, mountains erode, plates recycle crust. On Mars landscapes stay preserved. You can trace an ancient river from its source to its mouth as if it dried yesterday. Beautiful yet haunting. Beautiful because water always shapes land the same way. Haunting because they are empty, the rivers gone, the lakes dry, the ocean floor cracked. They remind us worlds change and life conditions can vanish. Early Mars must have been stunning. Rivers glimmering under pink skies, mountains casting shadows over valleys, clouds drifting slow. A river meeting a calm lake edged by greenish minerals. Maybe no living thing ever saw it, but the marks still speak. Through their shapes, sediments, and minerals they tell us Mars was once alive in its own way, a world of movement and possibility. Listening to them is listening to the shared language of planets shaped by water. Far in the north of Mars lies a wide low region called the Northern Plains. From space it looks smoother and flatter than the southern highlands filled with craters. It stretches thousands of miles like something once swept over it and left a clean surface. For years scientists wondered if that force was water, not streams or lakes but a vast ocean. The idea is not new. In the 1980s, maps showed the northern hemisphere sits lower than the south by several kilometers, a natural basin that could hold water over a third of the planet. On Earth such a basin would almost surely fill with ocean. More clues came from what looked like ancient shorelines, long ridges and terraces curving across the land, some thousands of miles. They resemble raised beaches or wave-cut cliffs, evidence of water lapping and retreating. On Mars, erosion is slow, so these shapes could last billions of years. They hint at tides shaping the land. The story these lines suggest is immense. Picture an ocean hundreds of meters deep in places, fed by rivers and lakes from the south. Volcanic heat, impacts, and a thick atmosphere could have kept it liquid for millions of years, with icebergs in winter and waves under a pale pink sky, an alien sea but strangely familiar. If such an ocean existed, it is gone now. To know why we follow the atmosphere. Early Mars likely had thick air that trapped heat and kept surface pressure. Pressure is vital because without it liquid water quickly freezes or vanishes. But as Mars cooled and its magnetic shield collapsed, the solar wind stripped air away, molecule by molecule over millions of years. As the air-thin temperatures dropped and water had only two fates, freeze or escape, the ocean would shrink into lakes, then ice, some locked in the polar caps, some buried underground, some lost to space. NASA's MAVEN spacecraft still measures air escaping today. Though slow now, it was enough over ages to erase seas. Isotope ratios in the air confirm Mars lost much water. Supporting the ocean idea, debates remain. Some think the shorelines might be lava flows or uplift instead. Others think the ocean may have appeared and vanished many times, forming in warm cycles from volcanoes or tilt shifts, then freezing again. If true, Mars had not one ocean but many temporary seas. Even with doubt, the ocean theory changes how we see Mars. Such a sea would be a cradle for chemistry, a place where nutrients mixed. On Earth, shallow seas often nurtured life. If Mars had life, a northern ocean was an ideal home until the climate turned. What makes it haunting is not only that the ocean is gone but how completely. Stand at the edge of the northern plains today and there is no shimmer, no waves, only silence and dust. The ridges remain but the sea they marked is erased. You can picture waves breaking but they never come. Earth's ancient seas leave shells and coral. Mars offers only rock patterns and minerals. Rovers and orbiters search for signs of long salty water, wave marks, and chemistry of habitability. Clues add up, but the sea is still only memory written in land shapes. Billions of years ago Mars may have been blue and red. Now it is only red. The change reminds us how fragile worlds can be. If you stood there in that age, you might have felt a thin breeze off the water, seen the sun scatter through a denser sky. But nights would still be cold, stars sharp over ice. The ocean already living on borrowed time. Now all that is left is the basin and the ghost of waves that will never crash again. The shorelines trace silence under a sky too thin to hold them. If you could visit Mars long ago, the first thing you might notice is the air, thick and warm enough to keep water liquid and soften the sun's harsh light. Today that air is almost gone. The Martian sky is held up by an atmosphere less than 1% of Earth's, a fragile veil that can barely cling to the planet. Where did it all go? The answer begins deep inside. Like Earth, early Mars likely had a molten core of iron and nickel. The motion of that core would have created a magnetic field, an invisible shield protecting the atmosphere from the solar wind. On Earth that shield still deflects particles, but Mars cooled faster. Its small size let the core freeze, the dynamo slowed and the shield failed. Without protection the solar wind swept directly against the air, knocking atoms into space over millions of years. The light gases went first, hydrogen and helium escaped. Then carbon dioxide and water vapor drifted away. Without thick air heat vanished, surface temperatures fell. Water froze into ice or evaporated, leaving dry channels. NASA's MAVEN mission showed solar storms still strip gas even today. Slowly but steadily, Mars' once blue dense sky became thin and dusty. Standing under it now would feel eerie, the light dimmer yet sharp. The sun 2/3 the size it looks from Earth, filtered through a haze of red dust. Breathing would be impossible not from cold but from lack of pressure. Your lungs could not draw in enough oxygen. Winds can reach 100 kilometers an hour, but the air is too thin to push hard. A fierce storm would feel like a gentle breeze, strange for a planet capable of dust storms covering the globe. The thin air changes the sky's look. By day the horizon is tan blending into salmon ground. Near the sun it glows yellow. At sunset the colors flip. Red light scatters away and blue sneaks through, making Mars one of the few places with blue sunsets. They are brief and pale compared to Earth, but haunting, without atmosphere heat. Escapes quickly. Days are chilly but nights plunge cold. Warmth has nothing to hold on to. Radiation from space also reaches the ground easily, hazardous for most known life. If life ever existed it would have been forced underground. Yet even in its weak state the sky has beauty. Dust paints gradients at dawn and dusk. Thin clouds of ice or carbon dioxide drift slowly and catch light in soft colors. The air is still. Silence unbroken by leaves or insects. The sky feels endless yet intimate. Every missing atom is part of a story billions of years long, of a shield lost and a climate transformed. The thin Martian sky is not just empty, it is a ghost of what was, the fragile ceiling of a planet whispering its history into the void. Mars is not only dust and desert, it also holds ice. The poles are capped with bright layers that grow and shrink with the seasons. In winter carbon dioxide from the thin air freezes into dry ice. In summer it turns back into gas. Beneath that shifting frost lies permanent water ice, stacked in layers like pages in a book. Orbiters have scanned them and found hundreds of layers recording cycles of climate. each line a chapter of tilt changes, storms, and sunlight. The southern cap is smaller, but thicker, the northern is wider and smoother. Both are dazzling under the dim sun, they gleam against the red ground. Beyond the poles ice is hidden too. Orbiters have spotted ice under soil in mid-latitudes, sometimes exposed by fresh craters, shiny and blue against rusty dust. This frozen water suggests Mars once had much more. Some melted into rivers and lakes, the rest locked underground. The presence of so much ice makes Mars different from a lifeless rock. It is a planet with reserves. Waiting, if humans ever settle there, this ice will be treasure, melted for water, split into hydrogen and oxygen for fuel and breathing. Even today ice shapes the planet. As air pressure changes, ice expands and retreats, carving cracks and ridges. Frozen carbon dioxide can even creep downhill like glaciers of dry ice, moving grains and sculpting slopes. Seasonal ice at the poles makes Mars dynamic. Each year carbon dioxide equal to a quarter of the atmosphere freezes out and returns. This breathing cycle changes air pressure worldwide, shifting winds, dust, and even the flight of future aircraft. Mars is still alive in these quiet motions. The polar layers are also records, like tree rings but older and stranger. They tell of how tilt wobbles, how sunlight waxes and wanes, how climate swings from warmer to colder. If studied fully, they might reveal not only Mars' past but also how planets breathe and change without oceans and forests. From Earth the caps look small, but if you stood nearby you would see endless ridges of ice, cliffs of frozen layers taller than buildings, bright and silent under a salmon sky. They are reminders that water has never left Mars completely, it just shifted, hidden in plain sight, sleeping under dust, waiting through ages, and whispering that even in a frozen world the story of water is never done. When people think of Mars, they often imagine mountains and craters, but the planet also holds canyons so vast they dwarf anything on Earth. The greatest is Valles Marineris, a system of chasms stretching more than 2,500 miles long and up to 7 miles deep. If placed on Earth it would run across the entire United States. From space it looks like a wound cut across the equator, a scar so immense it defies scale. Scientists believe it formed as the crust stretched and cracked, later landslides, lava, and water widened it. Today the canyons show cliffs, mesas, and valleys layered with colors from different rocks and minerals, each layer a timeline of Martian history. Standing at the edge would be overwhelming, the horizon dropping into shadow, walls carved with streaks of dust and ice. The thin air making distances look sharper than on Earth. The bottom of the canyon may still hide signs of ancient rivers or lakes, where water once pooled before evaporating. Valles Marineris is not one canyon but many, branching and overlapping, with side valleys and collapsed pits. It is a world within a world, some parts filled with landslide debris, others open plains, others narrow gorges. Explorers could spend lifetimes and not see it all. The scale is possible because Mars lacks active tectonics. On Earth, crust breaks into plates that shift and recycle. On Mars, the crust stretched without relief, creating cracks that grew into canyons. Nearby lies the Tharsis region with giant volcanoes. The weight of that volcanic plateau may have pulled the land apart, opening the canyons. Water may have helped too. Channels suggest floods once surged through side valleys, carving shapes like dry riverbeds. Dust devils still wander through them, lifting faint trails. Future explorers might find shelter in these depths, protected from radiation and storms. Caves carved into cliffs could hold ice or minerals. Even now orbiters study landslides and rockfalls, showing the canyons are not dead but slowly changing, like frozen rivers of stone. For those who dream of adventure, Valles Marineris is the ultimate frontier, larger than the Grand Canyon by far, silent and waiting, a monument to the forces that shaped Mars. Near the canyons rise the greatest mountains of Mars and of the Solar System. The most famous is Olympus Mons, a shield volcano almost 3 times taller than Mount Everest and as wide as the entire state of Arizona. It rises gently with slopes so shallow you could walk up without noticing you were climbing a giant. Only when you reach the edge and look down its cliffs miles high do you feel its size. Olympus Mons was built by lava flowing for millions of years, piling layer upon layer because Mars has no moving plates to carry the crust away. On Earth a hotspot creates chains like Hawaii as plates drift. On Mars the hotspot stayed fixed, building one monster. The summit holds a caldera 60 miles across, a collapsed pit where eruptions drain chambers below. It is surrounded by ridges, cracks, and lava plains frozen in place. Nearby stand 3 smaller giants called the Tharsis Montes, each taller than Everest. Together with Olympus Mons they form the Tharsis region, a plateau that reshaped half the planet. Their weight bent the crust, created faults, and helped open Valles Marineris. The scale of these volcanoes is beyond anything on Earth. Their lava flowed not for days or years but centuries, spreading plains hundreds of miles wide. Some flows still look fresh though they are millions of years old. Evidence suggests Mars had eruptions more recently too, perhaps only a few million years ago, meaning the planet is not completely dead inside. Smaller volcanoes dot the surface as well, cones, domes, and lava channels marking ancient fire. Volcanic rocks studied by rovers show chemistry shaped by heat and magma, signs of past eruptions that released gases into the air, thickening it for a time, maybe even helping water flow. volcanoes may have made Mars briefly habitable by warming and feeding the atmosphere. Today they are silent, but their size and stillness make them haunting. Walking across a lava plain at sunset, you would feel the history underfoot. Frozen waves of rock leading toward slopes that rise into the thin sky, Olympus Mons, and its neighbors are not only mountains but monuments, reminders of how powerful Mars once was, how fire shaped its land as much as water and ice. Standing on their summit, you would see the curve of the planet itself, the horizon bending away, a view that no mountain on Earth could ever give. Mars is also a planet of craters, from small pits to giant basins hundreds of miles wide, each one a record of impact from the early days of the solar system, when asteroids and comets rained down more often. Some craters are fresh with sharp rims and central peaks, others are ancient, worn by time and partly buried by dust and lava. One of the largest is Hellas Basin in the southern hemisphere. Over 1,400 miles across and several miles deep, if filled with water it would form a sea. Orbiters show fog and frost sometimes collecting at its floor, a reminder that even today these scars affect climate. Another great basin is Chryse, round and smooth with a ring of mountains at its edge. Smaller craters like Gusev and Gale have become famous because rovers explored them. Spirit landed in Gusev hoping to find evidence of a lake. Curiosity still roams Gale, climbing Mount Sharp in its center, studying layers that record billions of years of change. Craters are windows into the past. Impacts not only scarred the land but also shaped its geology. The energy of collisions melted rock, created minerals, and sometimes released water or heat that could last for centuries. In some cases, impacts may have made habitats for microbes, sheltered in cracks with warmth and chemistry. The craters also serve as timekeepers. The more craters a region has, the older it is. Smooth plains with few craters are younger, resurfaced by lava or floods. Heavily cratered highlands are ancient, almost unchanged since Mars was young. This method, called crater counting, lets scientists map the planet's history without digging. The surface is like a clock written in scars, yet craters are not only science but also beauty. From orbit they look like flowers or rings, with patterns of ejecta spread around them. Some have layered deposits hinting at lakes, others have dunes crawling across their floors. At night their shadows stretch across the land. Deep bowls under a pale sky, to walk in one would be to walk in history, surrounded by walls that echo with the memory of cosmic strikes. On Mars, craters are not rare features but part of the landscape, endless and silent, telling of a time when the sky rained stone and fire. Not all of Mars is craters and mountains. Much of it is shaped by wind. Over billions of years winds carve dunes, ridges, and strange patterns across the surface. Dunes on Mars can be tiny ripples or vast seas of sand stretching for miles. Some are dark, made of volcanic grains, others coated in pale dust. Orbiters watch them shift with the seasons, proving that Mars is not frozen but active. Even in its thin air, grains still move, sliding down slopes and piling in curves. Some dunes form crescent shapes called barchans, others form long parallel lines like waves on an ocean. Near the poles, frost coats the dunes in winter, then sublimates in spring, releasing gas that blasts through the sand, creating fans and spots that look like art. Elsewhere the wind carves yardangs, streamlined ridges of rock sculpted over ages. Some look like fleets of ships frozen in stone, others like waves frozen mid-crest. Dust devils also etch the land, their spinning paths leave dark tracks that fade with time, showing that even the quietest world still breathes. Rovers have driven across dunes, wheels slipping in soft sand, cameras catching ripples close up, the texture fine as powder. Scientists study these shapes to learn about wind speed, direction, and climate cycles. Dunes are not just scenery but evidence of how Mars still changes. Some dunes have moved measurable distances in just a few years. A reminder that even without rain or rivers, landscapes are alive. The wind also spreads dust across the planet, covering rocks, filling craters, and softening old scars. In places, winds uncovered bright layers of minerals, exposing secrets of the past. Explorers walking there would feel silence broken only by faint hisses of sand, grains sliding and bouncing in the thin breeze. Under the salmon sky the dunes would shimmer with subtle colors, tan, red, brown, even hints of blue or gray. Mars may seem still, but in truth it is restless, always shifting its coat of dust and sand, writing patterns that vanish and return with each season. The story of Mars is written not only in stone but in the endless patient work of the wind. At the poles of Mars lie great caps of ice, layered with dust, growing and shrinking as the seasons change. In winter, carbon dioxide from the thin air freezes out, forming a fresh layer of dry ice that covers the land in white. In spring it sublimates back into gas, feeding winds and storms. Beneath these seasonal layers lie permanent caps made of water ice mixed with dust, stacked in layers that hold a record of climate stretching back millions of years. Much like rings in a tree, orbiters have peered through with radar and mapped the hidden layers, showing spirals and terraces carved by wind and ice. Some cliffs reveal bright walls of pure ice hundreds of feet high, a treasure for future explorers. If melted, the water in the South Polar Cap alone could cover the whole planet in an ocean dozens of feet deep. The North Cap is broader and smoother, the South more rugged with deep pits. Both are active landscapes. Every year they breathe, expand, and contract, sending frost across the planet and pulling it back. The poles also shape weather, driving circulation of air, creating jet streams and dust storms. In summer the low sun circles the horizon, casting long shadows across the ice. In winter the caps vanish into darkness, locked in cold far below anything on Earth. Yet even here change continues. Dark streaks appear in spring as gas bursts through the ice, carving channels and spraying dust, creating patterns like spiders or fans, strange shapes unique to Mars. To walk near the poles would be to step onto a frozen desert, crunching across layers of frost under a thin blue sky, silence broken only by distant winds. Though deadly cold, the beauty would be haunting, white and red stretching to the horizon. The caps are not just frozen wastelands but records of a planet's breathing, proof that Mars is alive in its own slow rhythm, carrying memory of climates long gone and hints of what may come again. Mars is also a planet of seasons, tilted on its axis much like Earth. It experiences spring, summer, autumn, and winter, but each season lasts nearly twice as long because Mars takes almost 2 Earth years to circle the Sun. The tilt means sunlight shifts across the hemispheres, driving winds, storms, and changes in ice and dust. In winter the poles grow huge with frozen carbon dioxide. In spring they release it back into the air, stirring up pressure differences that create powerful storms. Summer brings warmth, though still bitterly cold by Earth standards. Autumn is a time of cooling and quiet. The colors of the planet do not change with leaves but with frost and dust, white creeping across the red land then retreating. Seasons shape not only the poles but the whole planet. Dust storms often rise in late spring and summer. Some stay small, others grow until they wrap the globe in haze, turning day into twilight for weeks. Rovers have waited in silence through these storms, their solar panels coated until sunlight returned. The seasons also affect where water frost forms. In some places morning brings a sparkle of ice that vanishes by noon. Orbiters have even seen clouds of water ice drifting in the sky, thin and fragile like veils, sometimes casting faint shadows on the ground. Explorers would feel these changes not as warmth but as subtle shifts in sky and wind, the sun riding higher or lower, shadows stretching longer, storms rolling across the horizon. To live on Mars would be to live by these slow but dramatic rhythms, each season with its own face, each one a reminder that even a dry, cold world is not still but part of the dance of the solar system, turning and tilting under the same sun that lights our own sky. Mars is famous for its dust storms, some of the largest in the solar system. Fine red dust covers the planet and the thin air lifts it easily. Small storms can rise anywhere at any time, swirling across valleys or plains, but sometimes they merge and grow, spreading until they cover continents. Once in a while they expand further until they wrap the entire planet in a blanket of haze. Day turns dim, the sky turns red, and the sun becomes only a faint glow. These storms can last weeks or even months, changing temperatures and winds across the globe. Rovers have felt them, light fading until their solar panels could no longer power them. Opportunity's mission ended in one such storm, silence falling as the dust blocked the sun. Yet storms also shape Mars, moving sand, covering old tracks, uncovering bright patches of rock. Dust devils race across the land, thin whirlwinds leaving dark trails as they sweep away surface dust. Some towers of dust rise half a mile high, caught from orbit as faint threads twisting in the air. Storms on Mars remind us that even in a thin atmosphere power remains, capable of changing the face of the planet. A world that seems still yet often awakens in great breaths of wind and dust. Mars is also a place of strange recurring features, marks that appear in certain seasons then fade away. One of the most mysterious are recurring slope lineae, dark streaks that creep down steep slopes during warm months, then vanish when it grows cold. At first they were thought to be water trickling through the soil, but later studies suggest they may be dry flows of dust or salty brine that seeps just below the surface. Their true nature is still debated. Whatever they are, they reveal that Mars is active today, not only in winds but in processes that respond to heat and cold. Other seasonal features include spider patterns near the poles, carved when carbon dioxide ice builds up in winter then bursts in spring, releasing jets of gas that carve channels beneath the frost. These fans and spiders spread across the land like delicate drawings, unique to Mars. Frost, clouds, and fog also appear. Water ice coating rocks in the chill of night, thin mists drifting in valleys, vanishing. With the rise of the sun, such features are small compared to giant volcanoes or canyons, yet they show that Mars is not only shaped by ancient forces but by living rhythms of today, a planet still breathing in its own way, carrying mysteries waiting to be solved by future explorers. Mars holds secrets beneath its surface, where the soil hides ice, salts, and rock. Orbiters with radar have seen layers of frozen water buried just below the dust. In some places cliffs expose bright walls of ice shining in the sun, frozen for ages yet still close enough to touch. Future explorers may dig wells here, melting ice for drinking water, for farming, and even for making fuel. Ice beneath the soil is proof that Mars once had much more water, perhaps oceans that later sank into the ground or froze away. Craters, channels, and valleys show clear signs of rivers that once carved the land. Minerals in the rocks tell the same story, formed only in liquid water. The buried ice is more than a resource, it is a record, holding tiny grains and gases from ancient times, clues to past climates, and maybe even traces of life if it once existed. To study this ice would be to open a time capsule of the planet, revealing what Mars was like millions of years ago, silent and hidden but holding answers that could change how we see life and worlds beyond Earth. Mars also surprises with signs of volcanoes. The largest in the solar system stand here, Olympus Mons rising more than twice the height of Mount Everest, so wide it could cover the whole state of Arizona, its slope so gentle that a person walking across might never realize they were on a volcano. Nearby stretch other giant shields, Arsia Mons, Pavonis Mons, and Ascrius Mons, all part of a vast volcanic region called Tharsis. These volcanoes are so large because Mars has no shifting tectonic plates like Earth, so eruptions kept building in the same place for hundreds of millions of years. Lava once poured across plains, carving channels and filling craters. Though most eruptions ended long ago, evidence suggests some flows may have been recent in geologic time, perhaps as little as a few million years, meaning Mars might not be fully dead. The giant volcanoes stand as monuments of a fiery past, their peaks so high they rise above thin air into skies where weather is different from the plains below. Explorers there would stand in awe of cliffs, lava plains, and horizons stretching farther than the eye could see, a land that tells of fire and power that once reshaped a world. Volcanoes are not the only signs of Mars's fiery past. The planet also shows deep scars from rifts and faults that tore its crust apart. The greatest of these is Valles Marineris, a canyon system so vast it stretches more than 2,500 miles long, nearly one-fifth the circumference of the planet, and in some places more than 6 miles deep. If it were on Earth it would stretch from New York to Los Angeles. A cut in the planet so large it can be seen from space with the naked eye, scientists believe. It formed when the crust near the Tharsis volcanic region swelled and cracked, pulling the land apart and creating giant faults. Later landslides, floods, and erosion shaped the canyon further. Its walls reveal layer after layer of ancient rock, like pages in a book of Mars's history. Within its depths lie valleys, mesas, and landslides the size of entire states. Dust and sand sweep across the floor, filling parts of the canyon, while other sections remain bare and jagged. Valles Marineris is not only a wonder of size but also of mystery, because some channels suggest water once flowed there. Perhaps lakes once filled its shadowed depths, leaving minerals behind. Rovers have not yet reached it, but orbiters continue to map it in detail, showing lands that future explorers may one day descend into. a journey like entering another world within Mars itself. A world of cliffs taller than any on Earth and horizons that seem endless within a single canyon. Canyons and volcanoes may dominate the land, but Mars also carries countless craters from ancient impacts, each one a story of collisions that shaped its face. The largest is Hellas Basin, more than 1,400 miles wide and 5 miles deep, a giant wound left by a massive asteroid billions of years ago. Its floor today is often covered in dust and frost, with winds carving strange patterns across the plains inside. Other craters are smaller yet still dramatic, showing central peaks, rings, and layers that form from the shock of the strike. Some hold signs that water once pooled inside, forming temporary lakes that may have lasted for centuries. Minerals in these craters confirm the past presence of water, and perhaps life could have found shelter there, protected from the harsh surface above. Impacts also delivered materials to Mars, scattering rocks from deep underground onto the surface where scientists can study them. While some meteorites were blasted off Mars itself and eventually traveled through space to land on Earth, where we now hold pieces of another world in our hands. Each crater marks not just destruction but also creation, new landscapes born in an instant, reminders of the violent history that all planets share. Standing at the edge of one would reveal towering rims, sloping walls, and vast silence, broken only by the wind. A sight at once terrifying and beautiful, showing how the universe leaves its marks across time. While craters, volcanoes, and canyons tell the story of Mars's violent past, the planet also whispers of gentler forces that once shaped it, forces of water, ice, and time. Scientists believe that billions of years ago Mars was far warmer and wetter than it is today, its atmosphere thicker, its surface crossed by rivers and dotted with lakes and perhaps even a great northern ocean. Evidence lies everywhere. Channels carved into the land that stretch for hundreds of miles, valleys where water once rushed with enormous force, deltas where rivers slowed and spread out, leaving behind fans of sediment just like on Earth. Orbiters have captured images of ancient riverbeds winding through craters and plains, their shapes unmistakable, dry now but etched forever in stone. Minerals found by rovers confirm that liquid water once flowed here, clay that forms only in wet conditions, sulfates and salts that remain after lakes dry away, signs that Mars was once a planet where water was common, where conditions may have supported life. One of the most striking pieces of evidence lies in Gale Crater, where NASA's Curiosity rover has been exploring since 2012. The rover discovered layers of rock that could only have formed at the bottom of a lake, thin sheets stacked one on another, showing that water was not fleeting but stayed for long periods. Curiosity also found organic molecules, the building blocks of life, locked in Martian rock. Not proof of life itself but proof that the ingredients were present. The mystery deepened. At Jezero Crater, the landing site of NASA's Perseverance rover, where a dried-up delta spreads like a fan into the crater's floor, a place chosen because it once held a lake billions of years ago, Perseverance is collecting samples there, tubes filled with Martian rock that one day may be returned to Earth for study, perhaps to reveal whether life ever began here. Water is still present on Mars, though not in wide rivers or deep seas. Today it hides beneath the ground as ice, locked away in permafrost, and at the poles where ice caps grow and shrink with the seasons, scientists believe that liquid water may exist deep underground, kept from freezing by pressure and salt. Radar from orbiters has hinted at these hidden reservoirs, though proof remains uncertain, yet even the surface shows hints. Streaks on slopes called recurring slope lineae may be linked to briny water flowing seasonally, though debate continues. Ice is easier to confirm, and orbiters have imaged cliffs where layers of pure ice lie exposed just below the dust, a resource that future explorers could tap to drink, to grow food, and even to make fuel. The presence of past and present water makes Mars not just a barren desert but a world of potential, a world that once may have been alive and that could one day support human life. The search for water is not only about survival, it is also about understanding, because water is the thread that connects life across the universe. Wherever we find it we find hope. On Earth it fills oceans, rivers, and skies. On Mars it lingers as memory and promise, a faint trace of a world that could have been. And perhaps maybe again. To stand by a dry channel on Mars would be to feel the silence of ages, to imagine the sound of rushing water that has not flowed for billions of years, to know that beneath the dust the planet still holds its secrets, waiting to be uncovered. If water tells us that Mars once had the conditions for life, the question that burns brighter than any other is whether life itself ever appeared here. Life on Mars has long captured human imagination, from early telescopes that saw strange lines across the surface and thought them to be canals built by intelligent beings, to science fiction stories of Martian invaders crossing the void to reach Earth. Yet today the search is quieter, more careful, based on science, not myth. We no longer expect to meet towering green creatures, but we do hope to discover something just as extraordinary, even the simplest form of life, a microbe that once lived in Martian soil or water, would change our understanding of the universe forever. It would mean that life is not unique to Earth, that given the right ingredients life will arise again and again wherever conditions allow. Scientists search for signs of past life in rocks that formed in water, because on Earth microbes thrive in such environments, especially in lake beds, river deltas, and hot springs. Perseverance rover is gathering samples from Jezero crater because the delta there is a prime candidate. Mudstones and clays could hold preserved organic material, tiny traces that survive even after billions of years. Curiosity has already found organics in Gale crater, though not yet signs of living organisms. Just the building blocks, and rovers carry instruments designed to study chemistry in detail, sniffing the air for methane, a gas that on Earth is often produced by life. Curiosity detected seasonal variations of methane, rising in the summer and falling in the winter, a mystery that scientists still cannot fully explain. Perhaps geological, perhaps biological, the planet holds its secrets tightly. If life still exists on Mars today, it would likely be hidden underground, shielded from the harsh surface, where liquid water may still seep through rock and where microbes, if they exist, could survive in darkness, protected from radiation. Extremophiles on Earth show that such survival is possible. Bacteria thrive in the deep crust, in acidic lakes, in frozen tundra. Even in vents at the bottom of the ocean where no sunlight reaches. If life can flourish in Earth's extremes, then perhaps Mars, too, could shelter survivors from its wetter, warmer past, organisms clinging on in pockets of liquid water beneath ice or stone, silent but alive. Future missions will bring new tools to the search. Plans are being made to return Perseverance's samples to Earth, where laboratories far more powerful than any rover's instruments will analyze them grain by grain, looking for structures, molecules, or isotopes that might signal biology. Other missions may drill deeper than before, reaching below the surface to places untouched by the harsh radiation. Someday humans themselves may explore with microscopes and labs right on Mars, able to test and confirm in ways machines cannot. And if we find even the faintest trace of life, past or present, it will not only answer the question of whether we are alone, it will raise new questions about how many other worlds might also be alive, across billions of stars. For now Mars keeps its silence, but every rock turned, every sample collected, every orbiting radar scan brings us closer to the truth, whether the planet is a barren wasteland or a cradle that once sheltered living things, whether we are unique or part of a greater cosmic pattern. Mars stands as a mirror for our curiosity, daring us to search deeper, to imagine more, and to keep asking questions as old as humanity itself. While the search for life continues, humans also dream of setting foot on Mars themselves, turning imagination into reality, sending people across millions of miles to walk where no one has walked before. Such a journey is not simple. It is the greatest challenge humanity has ever faced in space, yet step by step the path is being built: rockets, spacecraft, habitats, and technologies are all being developed with one goal in mind: to make humans interplanetary. NASA, SpaceX, and other agencies envision missions that would first send cargo, supplies, and robots to Mars, preparing the way before any crew arrives. Habitats must be placed, power systems must be deployed, and food sources must be tested, because survival on Mars means more than just getting there. It means staying, and staying safely. Astronauts would face months of travel just to reach the planet. More than 140 million miles at closest approach, a journey lasting 6 to 9 months each way. In deep space where Earth is just a blue dot and no rescue can come quickly, radiation is a constant danger. Microgravity weakens bones and muscles, isolation strains the mind, and every system must work perfectly, because failure means death. Still, the risk is what pioneers accept, and the reward is the chance to make history. Once on the surface, explorers would face a world harsher than Antarctica: cold that freezes steel, dust storms that last for weeks, thin air that cannot be breathed. Yet humans adapt, building shelters, wearing suits, generating oxygen, growing plants, harnessing energy from the sun and perhaps even from nuclear reactors. Each problem has solutions waiting in labs on Earth, tested again and again to prepare for the moment when they must perform for real. A colony on Mars would not begin with cities under domes, but with small outposts, clusters of habitats linked together, built partly from materials brought from Earth and partly from resources found on Mars itself, because to survive long-term humans must learn to live off the land, extracting water from ice, making fuel from the atmosphere, producing bricks from Martian soil, step by step turning a hostile world into a second home. The first explorers will likely live in cramped quarters, working long hours, facing danger each day, yet their mission will inspire billions. Children looking up at the night sky will know that people are there, walking among the red rocks, building the first outpost of humanity beyond Earth. Their courage will echo across generations, just as the Apollo moon landings inspired decades of discovery, but even more powerful. Because Mars is not a quick visit, it is a settlement, a frontier, a beginning of something larger. Dreamers talk of terraforming, of someday reshaping Mars into a world where humans could breathe freely, with rivers flowing and forests growing. Though such visions lie far in the future, perhaps centuries away, they show the scale of human imagination, the desire not only to explore but to transform, to take a dead planet and bring it new life. Maybe one day Mars will hold families, schools, art, and culture. A civilization born from Earth but unique in its own spirit, proving that life expands wherever it can, that boundaries exist only until they are crossed. For now the steps are smaller but no less bold, building rockets larger than any before, testing systems to land heavy payloads safely, creating habitats that protect against radiation, simulating Martian conditions on Earth to practice survival. Each advance is a brick in the road to Mars, and the dream moves closer, from science fiction to engineering, from vision to reality, until one day the words will be spoken that change everything, the first human voice calling out, "I am on Mars." Life on Mars will not be like life on Earth, at least not in the beginning. It will be closer to life on a submarine or in a space station, confined, careful, every action monitored because survival depends on systems that cannot fail. Astronauts and settlers will live inside pressurized habitats, walls thick with shielding against radiation, air carefully recycled, water filtered and reused endlessly, food grown in hydroponic farms under artificial lights, each bite a reminder of the fragile balance that keeps them alive. Yet even in such limits, human spirit finds ways to adapt, to create routines, to share meals, to laugh, to dream, because survival is more than breathing, it is about building community and hope. Daily life will revolve around work, maintaining equipment, repairing systems, conducting experiments, exploring the land outside. Each person will have duties as engineers, scientists, farmers, builders, and medics, no task too small, no mistake without consequence. Walking outside will require a suit that protects against freezing air and deadly radiation, moving slowly under lower gravity, each step deliberate, knowing the habitat walls are the only true shield from a world that cannot support them yet. Communication with Earth will carry delays of up to 20 minutes each way, meaning no instant conversations, no quick help. Every problem must be solved first by the crew themselves, a society forced to rely on trust, skill, and teamwork in ways deeper than any earthly job requires. Children born on Mars will know a different reality, growing up in low gravity, their bones and muscles developing in new ways, their lungs adapted to life inside controlled air, their games played not in open fields but in domes and tunnels, yet their minds will expand with the knowledge that they are pioneers, the first generation of a new world, looking through windows at red deserts stretching endlessly. Knowing Earth only as a distant light in the night sky, they will see Mars not as hostile but as home, and their culture will reflect that, shaped by necessity, resilience, and imagination. Art created with dust and stone, stories told of the journey across space, holidays celebrated not just for Earth traditions but for the milestones of Mars itself, the day the first habitat was completed, the day the first crops grew, the day the first child was born under another sun. Energy will be essential, solar panels stretching across the ground, capturing sunlight weaker than on Earth but still enough to power machines, nuclear reactors providing steady supply when storms block the sun, batteries storing every spark, because without power the habitats fail, water freezes, oxygen stops flowing, and lives end. Storage systems will ensure redundancy, backups for every critical need. Because mistakes are unforgiving, and planning is survival, exploration outside the settlement will open new opportunities, robots scouting ahead, humans driving rovers across plains and craters, mapping terrain, studying rocks, drilling for ice, searching for signs of past life, each mission adding knowledge and resources, step by step turning survival into expansion. As years pass, the settlement will grow, more habitats join together, greenhouses producing food, labs researching medicine, factories building tools, machines, and construction materials from local resources, Martian soil pressed into bricks, metals extracted from rock, water split into hydrogen and oxygen for fuel and breathing, a cycle forming where dependence on Earth shrinks and self-reliance grows. Trade may develop, with rare minerals or scientific discoveries sent back to Earth in exchange for technology and supplies, linking two worlds in partnership across space, a relationship unlike anything before in human history. But beyond survival and growth, life on Mars will carry deeper meaning. Settlers will look out at a night sky where Earth shines as a bright star, remembering that all of humanity is still there, yet also realizing that they are the bridge to the future, the proof that humans are not confined to one planet, that they can endure, adapt, and thrive on another world. Their courage will echo through generations. Just as seafarers once crossed oceans into the unknown, they too will be remembered as the ones who took the first step toward a destiny among the stars. As decades pass, small settlements on Mars will slowly transform into towns and eventually cities, no longer just survival outposts but true homes where generations are born and raised. Domes of glass and metal may rise above the plains, shielding people from the thin atmosphere while letting in filtered light. Underground tunnels may stretch for miles, connecting living quarters, farms, and laboratories, creating networks of life beneath the dust. What begins as modules brought from Earth will evolve into structures built with Martian soil and rock, bricks made from regolith, metals smelted from local ores, and 3D printed designs shaped directly on the planet itself, every building a sign of independence, every wall a step closer to permanence. And with each passing year Mars will stop feeling like a foreign place and start becoming a world shaped by human hands. Culture will grow with the cities, because humans cannot live only by science and technology. They carry with them music, art, rituals, and beliefs. Martian culture will be born from the conditions of the planet, songs inspired by the wind storms that sweep across the plains, paintings colored with red dust and gray stone, festivals timed not to Earth's seasons but to the rhythms of Mars, the day of landing remembered as a holiday. The longest storm marked as a time of reflection. Children will create games adapted to low gravity, their laughter echoing in domes where Earth-born adults once only worried about survival. Language itself may change as generations mix Earth dialects with new words born from Martian life. Communication shaped by distance, delay, and the unique experiences of living on a world unlike any before. Economy will emerge too, at first dependent on Earth, but slowly driven by local production. Agriculture inside vast greenhouses producing not just food for survival but variety for culture and trade, water mined from ice fueling both life and industry, rare minerals extracted and shipped to Earth in exchange for advanced technology, creating a cycle of interplanetary commerce. New jobs will appear. Terraforming engineers, radiation farmers, low-gravity architects, astrobiologists who study not only ancient traces of life but the new ecosystems humans create, each role vital for sustaining the expanding society. Mars will not just copy Earth's industries but invent new ones that only exist under Martian skies. Over time, science will push the boundaries further. Efforts at terraforming may begin, experiments with releasing greenhouse gases to warm the planet, building mirrors in orbit to reflect sunlight, spreading microbes to transform soil chemistry, all slow and fragile at first, but with centuries of persistence. Parts of Mars may gain thicker air, warmer temperatures, and liquid water once again. Forests and oceans may not come soon, but domes may open to skies humans can breathe beneath. Rivers may flow in valleys long dry, and fields may spread across plains where once only dust storms raged, a dream stretching beyond lifetimes but begun by those first who dared to land. Philosophy and identity will evolve along with technology. Martians will see themselves differently from Earthlings, bound by their struggle and triumph, proud of their survival. Children born under a different sky will carry a sense of separation. Earth will always be the cradle, the birthplace of humanity, but Mars will become the forge, where humanity proves its resilience. Questions will rise of governance. Will Mars be ruled by Earth or will it demand independence? Will it become a colony or a sovereign world? History shows that distance and hardship often spark freedom, and Mars may one day declare itself not just an extension of Earth but a new branch of civilization, with its own laws, values, and destiny. Yet through all this growth and division, there will remain a deep connection. People will look at Earth in the night sky as a bright star, remembering ancestors, family, culture, and origins, while Earth will look up and see Mars glowing red, knowing their children live there, the two planets bound by shared history and future, not rivals but partners in survival and exploration. Mars will not replace Earth but expand humanity's presence in the cosmos, showing that life can reach beyond one fragile world, and in doing so, giving humanity greater chances to endure whatever challenges the universe may bring. The rise of cities, culture, and independence on Mars will be more than just human expansion. It will mark the beginning of humanity's transformation into a multi-planet species, no longer tied to a single home, no longer vulnerable to one world's fate, but spread across the solar system, with Mars as the first great step. Every street built, every farm planted, every child born there will be part of that story. A reminder that the dream of reaching the stars begins not with leaps across galaxies but with steady footsteps on the dust of a neighboring world. As decades move forward, the outposts on Mars will no longer remain just temporary shelters of survival but will begin to transform into communities that breathe with life and culture. Settlements that at first were a cluster of domes and metal habitats will slowly expand into connected cities, linked by underground tunnels and surface transport. Every structure showing the slow shift from dependence on Earth to independence rooted in the red soil itself. Humans will learn to extract building material from Martian regolith, to smelt metals and print habitats directly on the planet, and with every wall raised by Martian hands the sense of belonging will grow stronger, for what was once an alien desert will start to feel like home. With settlements come families, and with families come generations who know no other world than Mars, children born under its dimmer sun and two tiny moons will carry an identity unlike any before, their games shaped by low gravity, their celebrations tied to the planet's seasons, festivals emerging not from Earth traditions but from Martian history itself, landing day becoming a holiday, storm season remembered with rituals, even the long night of power saving becoming a time of storytelling and reflection. Art will rise too, with music echoing through domes, paintings made with Martian dust, poetry inspired by silence and distance, and slowly a Martian culture will blossom, unique, proud, and enduring. An economy will form, fragile at first, built around survival, but expanding as technology deepens. Agriculture inside massive biodomes will move beyond feeding the settlers into providing trade goods. Engineered crops adapted to Martian soil chemistry may one day feed not only Mars but also export back to Earth. Water extracted from polar ice will fuel both human life and industrial processes. Minerals mined from deep beneath the surface may become vital resources, and new industries, like terraforming research, space manufacturing, or low-gravity construction, will arise that cannot exist anywhere else. Commerce will stretch between planets, a web of trade that binds Earth and Mars together across millions of kilometers. Governance will also become a question. At first, the settlements will be managed under Earth's agencies, space corporations, and treaties, but distance, delay, and the challenges of daily survival will give Martians a sense of independence. Slowly, a voice will rise asking, "Are we just a colony, or are we something more?" History on Earth shows that distance often breeds sovereignty, and Mars may follow the same path, declaring itself one day not an extension of Earth but a new nation, a new branch of humanity, with its own constitution, its own laws, and its own destiny under the alien sky. Science will not stop with survival. Humans will attempt to shape Mars itself, beginning experiments to thicken the atmosphere, to warm the surface, and to allow liquid water to flow again. Satellites may reflect sunlight to heat the cold land. Microbes may be engineered to release oxygen and change the soil. Gases may be produced to trap heat and create balance. Progress will be slow, measured not in years but in centuries. Yet every small change will push Mars closer to becoming a place where humans can walk outside with less protection, where domes may open to breathable skies, where valleys may carry rivers again, and though the full transformation may take lifetimes, the first steps will be remembered as the greatest works of human perseverance. Philosophy and faith will evolve in this environment. Martians will see themselves as pioneers but also as children of two worlds. Earth will be remembered as the cradle, the origin of life, while Mars will be seen as the forge where humanity tested its strength. Questions will echo through generations. What does it mean to be human when born under a different sun? Is our destiny tied to Earth or is it spread across the stars? And with time, Martians may no longer simply call themselves Earthlings living elsewhere but a people of their own, defined by courage, endurance, and the spirit of survival in the harshest of lands. Yet despite independence, there will remain deep bonds. When Martians look at the night sky, they will see Earth as a shining star, their ancestral home, the source of memory and connection, while Earth will gaze upward and see Mars glowing red, knowing their children live there. This bond will shape cooperation and conflict alike, but always remind both worlds that they are not alone, that humanity now spans more than one planet, and in that expansion lies resilience, security, and hope. The growth of Martian cities, cultures, and independence will not just be about space colonization, It will mark the beginning of humanity's transformation into a multi-planet civilization, no longer bound to one fragile world but spread across the solar system, with Mars as the first great proof that life can step beyond its cradle. Every dome, every harvest, every child born there will testify to the possibility of reaching the stars, for the path to distant galaxies begins with the footprints in the Martian dust. When the story of Mars begins to feel like a success, when domes shine in valleys, children laugh under weaker gravity, and Martian flags ripple in thin winds, humanity will look outward again, for curiosity never ends, and the drive to explore is endless. The next great frontier will not be another rocky neighbor but the giants of the outer solar system, Jupiter and Saturn, immense worlds cloaked in clouds, their secrets hidden in swirling storms and icy moons. Unlike Mars, these planets cannot be walked upon, for they are vast oceans of gas with no solid ground, yet around them circle dozens of moons, each a world of its own, and there the next step of humanity's journey will begin. Jupiter, the king of planets, with its great red spot larger than Earth itself, is not a place to settle, but its moons hold promise. Europa, with its cracked icy surface and hidden ocean beneath, has long whispered the possibility of life, while Ganymede, the largest moon in the solar system, possesses its own magnetic field and water deep below, and Callisto, ancient and battered by craters, offers stability for outposts. Settlers will not dream of walking on Jupiter, but they will dream of building floating research stations in its upper atmosphere, vast airships that drift above crushing depths, collecting data while harvesting helium-3, a fuel for future fusion reactors. And on its moons, bases will rise, built into ice and rock, powered by nuclear energy and solar arrays stretching above frozen plains. The journey to Jupiter will not be simple. It lies 500 million miles away, a voyage of years, not months, with radiation belts fierce enough to cook electronics and shielded habitats, but humanity will face these challenges as it faced the deserts of Mars. Massive spacecraft will be designed with rotating habitats to simulate gravity, with fusion engines to cut travel time, with layers of shielding to guard against radiation, and with autonomous AI to monitor health, energy, and navigation. Crews will travel in shifts, supported by supply ships launched years in advance, while robotic scouts land first to prepare, building landing pads, drilling into ice for water, and constructing the first shelters, so that when humans arrive, they step into a home ready to grow. As bases on Europa or Ganymede begin, explorers will not only search for survival but also for life, drilling through kilometers of ice to touch the subsurface oceans, sending robotic swimmers into the dark waters where alien creatures may hide, small or vast, microbial or complex, and should even the faintest sign of life be found, it will forever change how humanity sees itself. For to find life in another world within our solar system is to know we are not alone, to realize that creation is abundant, that the spark of existence is not unique to Earth. These discoveries will spark new debates, new philosophies, new faith, as humans ask, if life exists here, how much more must fill the galaxy beyond? Saturn will call too, its rings shining like a crown in the blackness, its moons offering opportunities that rival Jupiter's. Titan, larger than Mercury, cloaked in thick orange haze, with rivers and lakes of methane and ethane, will be a frontier unlike any other, a world where humans may sail alien seas, where submarines dive into chemical lakes, where balloons float through a nitrogen atmosphere thicker than Earth's, making flight easier than anywhere else. Enceladus, small and dazzling, ejects plumes of water from its south pole into space, hinting at hidden oceans beneath its icy crust, oceans that may too cradle life. To land there will be to stand at the edge of a cosmic mystery, to scoop frozen spray from geysers and taste the secrets of an ocean untouched by sunlight. The missions to Saturn will not come first, but they will not be far behind, for once humanity learns to reach Jupiter, the path to Saturn is only a step further. Great ships, built in orbit near Earth or Mars, will carry settlers in rotating rings, fusion engines pushing steadily across the void, taking years but bringing hope. Stations will be built in orbit around Titan, supplying landers and habitats on its surface, and slowly, humanity will learn to live not just near the sun but deep into the outer system, adapting to distances so vast that communication delays stretch over an hour, forcing independence once more, as Saturn's pioneers build not just colonies but civilizations with their own rhythms and time. The outer planets will test the limits of human endurance, for the cold is harsher, the nights longer, the distances greater, and yet in those challenges will be born new strengths. Children born on Titan will know skies of orange haze and lakes that glow in starlight. Children born on Europa will play in tunnels carved through ice, while poets will write of storms larger than worlds and of rings like frozen rainbows stretching across the heavens. The human spirit will expand, finding beauty not only in what is familiar but in what is strange and distant, and in that expansion humanity will take one more step toward becoming a species of the stars. Thus, the journey from Earth to Mars will prove only the beginning. The true destiny lies further still, in the giant worlds that shine like guardians of the solar system, and in the moons that wait like hidden gems. The call of Jupiter and Saturn is not only the call of science, not only the lure of resources or the dream of expansion, it is the call of destiny itself, whispering that humanity's home is not one planet, not two, but the cosmos entire. Beyond Saturn, farther than the golden rings and methane seas of Titan, lie the two forgotten giants of the solar system, Uranus and Neptune, worlds of ice and storms that few have ever imagined as homes but which will one day call to explorers with the same irresistible force that drew humanity to Mars and Jupiter. These planets are distant guardians, mysterious and cold, their blue-green colors shimmering in the dark, each one holding secrets buried in winds faster than any hurricane on Earth and in oceans of exotic ices that no human has yet touched. They are not easy places, not even kind places, but they are destinations that represent the true test of how far the human spirit is willing to go. Uranus, tilted on its side as if toppled long ago by a cosmic blow, spins differently from all other planets, its poles where other worlds have their equators, its seasons strange and long, with nights and days that last for decades. Around it circle moons with icy surfaces, Ariel, Umbriel, Titania, Oberon, and Miranda, each offering unique landscapes. Ariel shines with bright canyons cut into ice, Miranda bears cliffs taller than Mount Everest, and Titania hides beneath its crust the promise of subsurface oceans. While Uranus itself, like Jupiter and Saturn, cannot be landed upon, its moons could one day cradle bases, carved into ice for shelter against radiation, powered by compact fusion reactors or by harvesting the planet's own magnetic energy. Reaching Uranus will be one of humanity's most daring voyages. It lies nearly 2 billion miles away, a journey not of months or years but decades unless propulsion evolves. By then, humanity will not rely on chemical rockets alone but on fusion drives or even early antimatter propulsion, engines that can burn for years, pushing ships steadily forward through the frozen dark. These ships will be vast arcs of steel and light, rotating to create gravity, carrying hundreds of settlers in sleeping quarters, hydroponic farms, managed medical bays, and halls for learning and worship, for such journeys will not only be about science but about the survival of a culture traveling together into deep space. The explorers of Uranus will not look back to Earth daily as Martian settlers once did. Communication delays will stretch past 2 hours each way, forcing them into independence. They will be their own society long before arrival, learning to make decisions without Earth's guidance, forming their own traditions, celebrations, and ways of living. And when they finally reach orbit around Uranus, it will not feel like stepping into the unknown but like arriving home, for they will have grown into a people shaped by the journey itself. Neptune waits even farther, the last great planet before the edge of the solar system, a deep azure world of storms where winds roar at supersonic speeds, faster than sound itself. It is a planet of raw energy and beauty, crowned by its moon Triton, one of the most mysterious bodies in the solar system. Triton is unique, a captured world moving backward against Neptune's rotation, a moon with geysers of nitrogen spraying into space and a surface young and smooth, hinting at internal heat and the possibility of hidden oceans. To land on Triton will be to stand at the edge of the solar system and look outward into the endless night, with only the faint light of the sun and the glow of stars. Triton could become a bastion for deep space explorers, a port at the solar frontier, supplying ships that will one day sail to the stars. Its frozen plains could host domes and underground habitats, its geysers tapped for energy, its surface mines supplying metals for construction, while fuel depots are created to support missions beyond. For Neptune's orbit lies not far from the Kuiper Belt, a region of icy bodies, dwarf planets, and comets, and from there the pathway leads to the Oort cloud and the interstellar beyond. Triton could be the gateway, the last outpost before humanity truly leaves its birthplace and ventures into the galaxy. Life on Uranus or Neptune's moons will not be easy. It will be a life of cold extremes, of scarce sunlight, of distance so vast that the concept of home will change forever. Children born there will never see Earth's blue sky, but they will know instead the dance of auroras across Uranus's tilted magnetosphere or the faint glimmer of Neptune's sun. They will play in ice tunnels, study under domes that glow with artificial light, and learn to navigate a universe where the stars are no longer unreachable but neighbors waiting to be visited. These worlds will teach humanity patience, endurance, and imagination. They will force technology to grow. For survival there demands inventions not yet dreamed of, fusion power harnessed reliably, closed ecosystems perfected, autonomous construction perfected by AI, genetic medicine to keep bodies strong against radiation and low gravity. And as humanity learns to thrive even at the edge of the solar system, confidence will grow that the stars themselves are not too far. Thus, Uranus and Neptune are not destinations of resources alone but of transformation. To reach them is to admit that nothing in the solar system is beyond reach, that human will and creativity can carve life into any place, no matter how distant or hostile. They are the final stepping stones before the leap beyond, the last lessons in survival before the true unknown begins. When outposts rise on Triton, when ships harvest the icy rings of Uranus, when the laughter of children echoes under alien skies, humanity will know it has become not just a planetary people, not just a solar people, but a species ready to leave its cradle forever. Life on Uranus or Neptune's moons will not be easy. It will be a life of cold extremes, of scarce sunlight, of distance so vast that the concept of home will change forever. Children born there will never see Earth's blue sky, but they will know instead the dance of auroras across Uranus's tilted magnetosphere or the faint glimmer of Neptune's sun. They will play in ice tunnels, study under domes that glow with artificial light, and learn to navigate a universe where the stars are no longer unreachable but neighbors waiting to be visited. These worlds will teach humanity patience, endurance, and imagination. They will force technology to grow. For survival there demands inventions not yet dreamed of, fusion power harnessed reliably, closed ecosystems perfected, autonomous construction perfected by AI, genetic medicine to keep bodies strong against radiation and low gravity. And as humanity learns to thrive even at the edge of the solar system, confidence will grow that the stars themselves are not too far. Thus, Uranus and Neptune are not destinations of resources alone but of transformation. To reach them is to admit that nothing in the solar system is beyond reach, that human will and creativity can carve life into any place, no matter how distant or hostile. They are the final stepping stones before the leap beyond, the last lessons in survival before the true unknown begins. When outposts rise on Triton, when ships harvest the icy rings of Uranus, when the laughter of children echoes under alien skies, humanity will know it has become not just a planetary people, not just a solar people, but a species ready to leave its cradle forever. Beyond Neptune's dark storms lies Pluto, once called a planet, now known as the King of the Kuiper Belt. It is a world of frozen plains and mountains of water ice that rise like jagged teeth, with a thin sky of nitrogen that glows faintly under the distant sun. Pluto is not merely a cold rock, but a symbol, a reminder that every corner of the solar system carries mystery. Its heart-shaped plain, Tombo Regio, shines like a beacon, whispering that even at the farthest reaches, there is beauty and hope. To land here will be to stand at the edge of what was once thought possible and see the universe open wider. The Kuiper Belt stretches beyond, a realm of icy bodies, dwarf planets like Eris, Haumea, and Makemake, and countless comets frozen in silence. This is the solar system's treasure chest, filled with water, methane, and carbon compounds that can sustain colonies and fuel ships. Here, humanity will mine ice to create propellant, hollow comets into habitats, and transform drifting rocks into way stations of life. The belt will become a highway, dotted with settlements like stars, connecting Neptune's orbit to the true frontier. Farther still is the Oort cloud, a vast sphere of comets surrounding the Sun like a ghostly shell, stretching almost halfway to the nearest star. It is here that humanity will finally feel the pull of other suns, for standing on a comet at the edge of the Oort cloud, the Sun is no longer the great blazing orb of Earth's sky but just another star among many. To reach the Oort cloud will be to whisper farewell to the cradle that has held us since the dawn of time. From here begins the interstellar road. The nearest star, Proxima Centauri, lies 4.24 light-years away, a gulf so vast that even at unimaginable speeds it is a journey of decades or centuries. But by the time humanity reaches the Oort cloud, the technology will exist. Fusion engines that burn for generations, solar sails pushed by lasers from Earth and Mars, antimatter drives blazing like artificial suns, even experimental warp fields that bend space itself. Ships will not be small rockets but living worlds, rotating habitats carrying forests, rivers, and entire societies. They will sail not as explorers alone but as civilizations in motion. Children will be born aboard these interstellar arcs, never knowing Earth but hearing its stories as myths. Their sky will be the metal walls of their ship, their playgrounds will be artificial valleys under starlight lamps, and their destiny will be to arrive at other suns and make them home. Planets orbiting red dwarfs, yellow suns, and blue giants will become seeds for human dreams, each one a chance to plant life where none existed before. Humanity will no longer be of Earth, or of Mars, or even of the solar system, it will be of the stars. And yet, no matter how far humanity travels, the memory of Earth will remain. The blue oceans, the green forests, the cradle where it all began, these will live in songs, in prayers, in stories told to children born light years away. Earth will be remembered not as a place left behind, but as the eternal first home, the mother of all journeys. This is the destiny of humanity, to rise from one small planet, to cross the moons and giants of our solar system, to step beyond Pluto into the dark, to turn the stars themselves into homes, and to fill the galaxy with life, light, and hope. The story of exploration has no final chapter, only new beginnings written in the glow of distant suns. The universe is endless, and so is the human spirit.